my name is Jason Foster. Today we'll be using concepts of physics to analyze the final free kick scene from one of my favorite movies, Goal, The Dream Begins. In this scene, the main character, Santiago, scores the winning goal in the all-important game off a free kick. Let's watch the scene. Using information from the scene, we can figure out the distance from the ball to the net. From the dimensions of a soccer field, we know that the distance from the net to the goal line is 2 yards, and the distance from the goal line to the edge of the box is 18 yards. It also appears that the distance from the edge of the box to the ball is 3 yards. This makes a total of 23 yards from the ball to the net before the ball is struck, which is equal to 21.03 meters. Next, we need to figure out the time elapsed in the scene from when the ball is struck until it hits the net. Using a stopwatch, the time in the scene is measured to be 1.59 seconds. However, this scene occurs in slow motion. In order to fix the slow motion problem, we can use another scene from earlier in the movie, when Santiago is taking free kicks with the exact 3-step run-up as in our scene of interest, but it is in real time. Let's watch that scene. Now, watching his 3-step run-up more closely, a stopwatch is used to measure that the 3-step run-up to the ball takes 1.52 seconds in the real-time scene. Going back to the slow-motion scene, a stopwatch was used to find that the same 3-step run-up takes 2.87 seconds. In order to calibrate for the slow motion, we have to recalculate the slow motion factor by dividing the slow motion time by the real time for the same 3-step run-up. Dividing 2.87 seconds by 1.59 seconds gives us a slow motion factor of 1.81. Using the slow motion factor, the actual time elapsed from when the ball is struck until it hits the net in the original scene is 0.878 seconds. Now, knowing both the distance that the ball traveled to hit the net and the time that the ball took to travel that distance, we can determine the speed of the ball on its way to the goal. This speed comes out to be 23.95 meters per second, which equals 53.57 miles per hour. This would actually be a rather accurate speed for a soccer ball struck by a professional soccer player to be traveling, as the average speed of a ball shot by professional soccer players in real life is 63 miles per hour. However, Zlatan Ibrahimovic, one of the top players in the world, scored a goal with a shot clocked at 90 miles per hour 2 years ago. Next, we can analyze the collision that occurs when the ball strikes the net, using the concepts of conservation of energy and conservation of momentum. As we previously determined, the ball is traveling at a speed of 23.95 meters per second before the collision, and the mass of the Nike Ordom ball that is used in the movie is 0.435 kilograms. At this point, the speed of the stationary net is 0 meters per second, and the mass of the section of net that will be struck by the ball is 0.0189 kilograms. The mass of the section of net that will be struck by the ball was determined by estimating the ball strikes about 1 foot worth of net. For the dimensions of 8 feet by 24 feet by 3 feet for the net on a professional soccer goal, the total amount of net is 576 feet, and the total mass of the net is 10.89 kilograms. Dividing 10.89 kilograms by 576 feet, we get that the mass of the section of net colliding with the ball is 0.0189 kilograms. Now, using the kinetic energy equation of Ke equals 1/2 mv squared, with the ball's mass of 0.435 kilograms and speed of 23.95 meters per second, we find that the total kinetic energy before the collision is 124.95 joules, because the stationary net adds no kinetic energy. Using the same information and the momentum equation of P equals mv, the total momentum of the ball before the collision is determined to be 10.42 kilogram meters over seconds. After the collision, when the ball strikes the net, the combined mass of the ball and net is 0.454 kilograms, but we do not know the combined speed of the ball and net. According to the law of conservation of momentum, the momentum after the collision must still equal 10.42 kilogram meters over seconds. Inserting this into the momentum equation P equals mv, we find that the combined speed of the ball and net is 22.95 meters per second after the collision. Then, this combined speed can be inserted into the kinetic energy equation along with the combined mass to find a kinetic energy of 119.56 joules after the collision. The law of conservation of energy states that the total amount of energy must remain the same, but according to our calculations, there is 5.39 joules less of kinetic energy after the collision as compared to before the collision. This 5.39 joules was most likely converted into heat energy and sound energy when the ball struck the net. Now that we know all of this interesting information about the scene, let's watch it one more time. And thus concludes our physics analysis of the great free kick scene from the movie Goal, The Dream Begins. If you have not seen this movie, I highly recommend it. And who knows, maybe you'll even find some more scenes to analyze using your great physics knowledge. Thank you very much.